Good morning, everyone. Today, we'll be continuing our lectures from where we left off yesterday. Right. Okay. Yeah. All right. So yesterday we spoke about general principles and guidelines about postgraduate level research, and today I'm going to show practical applications, okay, based on data analysis conducted in SPSS and Stata softwares. And a few minutes ago, I have given a copy of our license to Yoas, and so he will communicate with you guys by email, and he will be able to assist you. So if you need to install Stata software, you may ask him for assistance, and you may need a laptop, and on that laptop he will help you to install Stata software. And once he installs the software, the license is a permanent license. It does not expire, so you can keep working and improve your skills. So your proficiency in utilizing any of the statistical packages depends on how often you practice. So in order for you guys to practice freely, you got to have the license on your own laptops. Okay, so you need to communicate with Yoas, and Yoas will help you, okay, for installing the software on your laptops. Do you have laptops? Yes. Okay, so you see, a laptop is a basic necessity. If you are required to do postgraduate level research, then you need to have your own laptop, and you must not feel sorry about having to buy a laptop. It's a worthwhile investment, and you buy yourself a good laptop, install data sets, lecture notes. Thank you. Okay, thanks. So you may install your lecture notes, install your programs, and you will be able to do data capturing and analysis. So today, I'm going to demonstrate data analysis in two softwares. The first software is Stata software. The next one is SPSS. Now, I believe, see, look at the names there. Okay, SPSS. Is it possible to maximize this, or is it possible to? What do we do that? Is it okay? Right, something. Right. So, just a little bit of background about SPSS. SPSS is an American statistical package. The head office of SPSS has always been in Chicago, the state of Illinois in America. Okay, thank you. Statistical packages for the social sciences, SPSS. Okay, it's an acronym. Statistical packages for the social sciences. Many years ago, in the early 80s, I remember SPSS was in the market, and it was a very popular statistical package, and it rendered services mostly to social sciences students. However, things have changed, and the manufacturers of SPSS have added so many functions and programs into SPSS, and today SPSS is used in many disciplines like science, engineering. You can even do mathematical algorithms, estimations in SPSS, and SPSS is no longer a statistical package for the social sciences. It welcomes everybody. And the license for SPSS expires once a year, and by contrast, the license for Stata does not expire. Okay, it's a permanent license, and once you have Stata software on your laptop, okay, the program will keep working. And you really, like I said yesterday, if you would like to improve your skills on data capturing and analysis, you got to practice. Now, to practice, you need access to your softwares. Okay? The software must be available to you at all times. In order for you to practice, you got to have the license. Now, if the license is not available, surely you will be constrained. You will not be able to practice at any time of your convenience, and therefore, it will come out as a hindrance. Yeah. Sorry. Yes, okay. Okay. All right, thank you. I think this is it, eh? Okay, thanks. All right, so now what I'll do is I'm going to, now this is general information, eh? Now, TUT pays license for SPSS. It has an annual license. However, to get your license, what do? You communicate with the IT department. There is a colleague of mine, his name is Gift Shabalala. He works for the IT department. Gift Shabalala is an employee of the IT department, and to the best of my knowledge, he is all the time, he is the guy responsible for installing SPSS. He has assisted many students at the business school. He has assisted many academic staff in TUT. And I think Joas will be able to give you his contact details. And once you get his contact details, you may send him an email and ask him for assistance. And once you make an appointment with him, he will be able to install SPSS for you. Right. Now, about Stata, now you can also communicate with Joas. He will be able to give you the software plus the license. Okay, the license belongs to the business school, and our students are authorized to use the license. Okay, so I think that's the basic info you needed to know. Now, for the last time, let's just recap. The use of a software will not alter, okay, your results of data analysis. So your results of data analysis will not vary depending on what statistical software you have had to use for data analysis. You just have to know how to use the statistical package of your choice. You need to know how to interpret your findings by looking at the printout. And as long as you know how to interpret your findings, your results of data analysis, then nothing will change. Whether you use SPSS or SAS or Stata software or Excel for that matter, Minitab, StatGraphics, a number of packages are around here, S+. Now, it doesn't matter which statistical package you use, your results will be the same. It's like the choice of a car to drive from Pretoria to Johannesburg. What really matters is that you know how to drive the car is roadworthy, and you are in a mood to respect the laws of the road. You are sober, and therefore it doesn't matter which car you have chosen to drive in order to go from Pretoria to Johannesburg. So you must not be worried about the choice of a statistical package. Now, today's lecture is to demonstrate that results obtained from Stata software are exactly the same as results obtained from SPSS software. The results are the same. The steps are clearly outlined in the handout. They are articulated, and today we're going to reproduce the results of data analysis you already have in your handouts. Okay, so that will reinforce your memory. It will give you some confidence. Okay, and now let's just get on with exercises. Now, the first example I would like to give is about how you could set up, okay, how you could open up a dedicated root directory on your laptop. Okay, if you are an efficient, clever, disciplined student, you got to have a dedicated folder on your laptop. And I would like you to go to C, okay, the root directory C, and in C, you open up a small folder, and you can call that folder anything, but I prefer BOS, okay? So BOS, okay, lowercase b, lowercase o, lowercase s, and at the root K, I say root directory C, create a folder called BOSS. Okay, here are the steps. You go to Windows Explorer, right-click at any space, and create a new folder. See new, and so see folder, override folder by BOS, and then C BOSS should be created. Okay, you go to C. So basically, this is what I'm talking about. You go to now. In order to go to C, there is something. Can you see this? Local disk. And now you are on C. And right-click meaning like this. And then you go to New. And then you go to Folder. Now when you go to Folder, you can overwrite folder by BOS. And you have just created a folder called BOSS. Okay, the steps are outlined. Okay, can you see this? Here are the steps to be followed. Look at these steps. Now if you follow these steps, you will definitely know how to create it. Okay, so these handouts are tailor-made to the students' needs, and therefore, if you follow each of the steps here, you will definitely be able to reproduce what I have done here. Okay, they are made specifically so easy to follow, no step has been omitted, therefore, you must not panic about this. It's an easy, straightforward operation. Now, you need to have a dedicated folder in order to save all your files in that folder and to save everything like data sets, instructions, notes, and any notes you would like to add. You know where to go and so on. Now, let's go to C BOSS. Have a look here. Now, I go to Explorer and you go to C, and under C, you will see BOSS. Can you see this? I've saved so many files here. Okay, so if I need anything, I just go to C BOSS. So now let's have a look here. How to set up the combined layout in Stata. Have a look here. Now this is Stata software. Okay, double click on Stata, and you go to Edit, and you go to Preferences. The steps are written, and you go to Load Preference Set and Combined Layout. And this is what Stata gives you. See here, top left, you will be able to see your Stata commands. Okay? Bottom left, you will be able to see your variables. Right in front of you, you will see your results of analysis. And here, the command prompt line. If you know the Stata commands to be typed, then you type out the commands. If you are a new beginner, if you are new to Stata, what do? Instead of typing out the commands, you go to Statistics and follow the menu. You will identify what to see, you will know, okay? You will know what it is you're looking for. Therefore, you execute that. Stata will give you the corresponding Stata command so that you remember it next time around. It's a very intelligent software. Whether you follow the menu or you type out the commands, the procedures are the same. An experienced user will know what Stata commands should be typed out. You type out the commands, you get what you need. By contrast, if you are new to Stata and you do not know what commands to type out, what do? You follow the menu. Now, example. Let's first of all open up a file. Okay, nothing happens before you open up a file. Now, to open up a file in Stata, it's like opening up a file in MS Word. Okay, you go to File and you click on Open. Do you see what I'm saying? And now where do you go? You go to C and go to BOSS. Why? That's where you stored all your data sets and your notes. You remember, Yeah. Everything you get from me, meaning the raw data sets, the lecture notes, the remarks, and everything, you take it to C BOSS. So now when you come into Stata and open up a file, you go there. Because all the things you have are available for you in CBOSS. So now in CBOSS, let's look for a data set called BOSS1. Okay, BOS1. It's available here. Okay, BOSS1, BOS1. I think, yeah, here it is, BOS1. Yeah. So you click on open, and what happened? The file got opened. Now please let me demonstrate something. What did you see here, top left? Do you see the stata command? Click on that stata command, and what happened? It got displayed on the command prompt line. Now press enter. What happened? Stata executed that command. Anything you do, stata gives you the corresponding stata command, and it serially numbers every unique stata command so that you know what it is you have been doing. Okay? So now I have opened up the stata command. Can you see the stata file is here? Now the variables are here. The commands are here. The results of data analysis are right in front of you. And the command prompt line is here. Now, let's go to the data editor window. Here it is. Data editor edit. Click on it. And can you see the types of variables you have? Column 1 is ID. Column 2 is age. Okay, the age of respondents in years. For example, respondent number 1 is 42 years old. And the gender, okay, that column is called sex. Okay, what's the gender of respondent number 1? Male. Respondent number 2 is female, and so on. Now, the third, can you see this one? Sex rec, recorded. Okay, values of sex recorded as 1 and 2. Okay, marital status, there are 5 categories, and the possible values vary from 1 to 5. 1 for married, 2 for single, and so on. 3 for divorced, 4 widowed, and category 5 for everything else, like living together. Okay, so what you do is you move to the right now. Okay, have a look here. Race, can you see this? Now the possible values are black, Indian, colored, white. So you carry on, you move to the right in order to see what kind of variables you have here. Can you see? You have all sorts of variables here. And therefore, now let's do some analysis. Okay, the simplest possible analysis you can do is frequency tables. Do you understand that? It's very important for you to understand the basics. Now, don't believe when people say to you, to analyze data sets, you need specialist skills and so on. It's not true. You can educate yourself, you can empower yourself. All you need to do is sit down here, sacrifice a few hours to fiddle around, and then master some basic skills. You can use the handouts you have with you to do that. Okay, these handouts are tailor-made to what it is you're gonna need in the course of data analysis. The most commonly used statistical procedures are inside these handouts. Now, when you do postgraduate level research, okay, go to the library, get yourself a copy of one of the dissertations and have a look. The results of data analysis section begins with what? A simple frequency table. Okay? It talks about the gender distribution of respondents. Males. These many of my respondents are male. The remaining ones are female. Now, instead of numbers, the writer provides what? Percentages. Like 40% are male, 60% are female. And then what happens? You will see a pie chart. Okay, the pie chart is split into 2. Okay, one of them for males, the other one for females. And that is followed by what? A narrative. Okay, now if you take the dissertation written by Naledi, the moment you get into the results of data analysis section, the first narrative you find will be about the dependent variable of study, and she says this is a graphical depiction about what percentage of my applicants succeeded in getting a loan for their businesses. Yeah. In principle, approval does not necessarily mean you're going to get the loan. Okay? You may be denied the loan. Yeah. So finally, she gives, she provides a pie chart, and you will know how many of them actually ended up getting the loan and how many of them were denied the loan. Okay? Absolute numbers and percentages. Which of the two is preferable? I prefer percentages. Okay? And then there's a narrative. She gives a narrative by saying, contrary to what has been promised to small enterprises, okay? The fact is, very few of them are getting loans from microfinance institutions. And forget about the commercial banks. The commercial banks demand collateral. If you fail to produce collateral for the loan amount you are applying for, the answer is a no. They wish you well, they may give you a cup of tea, they may talk to you nicely. However, moment of truth, they will say to you, your loan application has not been successful. So, now do we understand each other? So, when you do research, your results of data analysis begin with the most elementary, the most trivial issue, like what percentage of applicants were granted a loan? What percentage of them were denied a loan? What percentage of your applicants were male? What percentage of them were female? So now have a look here. This is a data set. I would like you to familiarize yourselves with this data set. This data set is a result of some research done in KwaZulu-Natal, okay, at the end of 2000. We had a cholera outbreak in KwaZulu-Natal. I don't know how many of you remember that. We had a cholera outbreak at the end of 2000. And so some research was done in KwaZulu-Natal, okay? And the sample size of study was 181. And what happens is, now you will see how many of them boil drinking water. But look, to boil drinking water, you got to be educated. Okay? So why is it necessary to boil water? See, when it rains, and if the rainy season goes on forever, okay, the rain will result in contaminated water. And now before you drink, what do? You boil the drinking water and you will be safe. If you do not have the means to boil drinking water, and most importantly, if nobody has educated you, if no community health worker has given you a lecture or a home visit to let you know that it is risky to drink unboiled water, what happens? You drink unboiled water and you may have diarrhea. You see? So you must be very careful. Now, in this research, we will obtain frequency tables. Now let's start here. Look, statistics, and then you go to summaries, tables, and tests. And please go to frequency tables. And can you see something that says multiple one-way tables? Okay. Click on multiple one-way tables. And let's choose a categorical variable here. Okay. Sex is categorical. Okay. Age is not a categorical variable. It's a continuous variable. Okay. Let's choose marital. It's another categorical variable. Let's choose race. Let's choose toilet. Now these are examples of categorical variables. And now you click on OK. Can you see what happened? Look, Stata gave you command number 3, okay, with a Stata command which says TAB1 followed by categorical variables. And what are these? Sex, marital, race, and toilet. Now for the 4 categorical variables, you would like to have a frequency table. Now look at what the Stata has given you. Now have a look. See, first it opened the file, then it gave you frequency tables. Now let's interpret the frequency table for gender. How many of them are female? 126 out of 181. The percentage will be 69.61%. Okay, for males, you have 55 out of 181 males, and the percentage will be 30.39%. Can you see that? So, can't you sketch a pie chart to depict this information graphically? Is it difficult to do so? No. You can easily sketch a pie chart. And you provide a narrative, and now you are discussing results of data analysis. So this is a fairly straightforward operation. Now let's do the same thing in SPSS. Okay, let me go to SPSS right here, and let's open up the file. File, open. And you see, the data set I'm talking about is boss1.sav. Okay, click on it. And this is it. Okay, here is your data set. Now, you go to statistics. Now, have a look, sorry. You click on analyze. And you go to descriptive statistics. And you go to what? Frequencies. And select the variable sex. Okay, take it to the right. Marital, take it to the right. Race, take it to the right. And toilet, take it to the right. And now when you're done, you click on OK. And you will see the same results obtained from SPSS. The results are identical. The rest is a matter of convenience. You copy your results, take it to MS Word, paste it, and you keep writing. So it doesn't matter what statistical package you use, your results are the same. Now let's go back to our handout. Now here is our handout. Okay, this is it. Now look at this. How to set up the combined layout of Stata. See, you click on Edit, click on Preferences, click on Load Preference Set, click on Combined Layout. Okay? The next one will be, now look, at this stage, Stata will display 4 partitions. Okay? The next one says top right corner. Can you see that? Now the next one will be how to capture data in SPSS. Okay, this is how to capture data. Actually, the simplest method of capturing data will be in Excel. Okay, I always encourage my students to capture data in Excel. From Excel, you copy and transfer your raw data set to any package. Okay, there are no statistical packages that do not work in harmony with Excel. Okay, so if you know how to capture data in Excel, from Excel you can take it to any statistical package of your choice. Right, so have a look here. This is how you do data capturing in SPSS. Look, enter SPSS. So you will be on the data editor window, click on variable view, you assign the variable name, define age as a numeric variable, and blah, blah. Look, follow all these instructions, and finally click on data view, and then you will have this data set. This data set has been saved as stat1.sav. Okay, now let me demonstrate. Now let's go to Stata, SPSS, and open up the file. I don't want to save this. Okay, save changes, no. Now what I will do is, I go to SPSS, I want to open up Stat1, just to show you, what it looks like. File, open. And then you go to data, and let's open up Stat1, that one. Okay, this is the data set I'm talking about. So you can capture data in SPSS by following those steps. Okay, and the reason why I gave you these handouts with all those detailed steps is to allow you to sit down, open up your laptop, and then to reproduce what you see in your handout. Is that right? Look, because everything is clearly documented, you do not have to remember or take notes during the lecture time. All you do is open up the machine and open up your handout. Okay, it will help to have a hard copy, and then reproduce what the handout says. And then you do that again, what happens? You will be able to internalize those skills, and you will get better and better. Okay, practicing. So now let's have a look here. Okay, the first column is what? Age. The next column is gender. The next column is weight. Then you have race. Then you have height. Now, can you see that age is a continuous variable? Gender is categorical. There are only two possible values of gender. You could have male or female. Now the weight in kilograms is a continuous variable. It has 2 decimal digits. The race, how many possible values do you have here? 4. Okay, it's categorical. Now the height of the individual in centimeters, in meters, 1.56 and so on. Now this is a continuous variable. So for categorical variables, you need to demand frequency tables. Okay, for any categorical variable, the correct procedure is frequency tables. Are we clear? For categorical variables like race category, language group, marital status, okay, you ask for a simple frequency table and you interpret your frequency table. It makes sense to say 45% of my respondents were male, 55% of my respondents were female. Okay, that is baby step number 1. Okay, step number 1 of data analysis is to acknowledge that for categorical variables, you need frequency tables. You supplement frequency tables with pie charts if you have 3 or fewer categories. If your number of categories is above 3, you should rather use a bar chart. Example, if you have 5 possible categories, okay, you construct a bar chart. And the best statistical package for sketching a bar chart and a pie chart is what? It's no other than Excel. Okay? Excel is a very useful statistical package. It does so many calculations. You can even write your own programs and execute them. Now, do not underestimate Excel, but I love Excel for sketching graphs. You can edit your graphs, you can make amendments. There you go. So when you send your dissertation to your supervisor for a review, please remember to also attach your Excel graphs. Because if some things have to be edited or changed, okay, the Excel graph will come in quite handy. You cannot edit from MS Word. Do you see what I'm saying? And do not expect your supervisor to go and resketch the graph on your behalf and then do the edit. No, nobody will do that. So just remember, now what we'll do is, this is SPSS. Now in SPSS, if you go to analyze, just have a look here, analyze, and you go to descriptive stats, you go to frequencies. And let's select the categorical variables. Age is not a categorical variable, therefore you skip age, you pick gender. The next one, weight in kilograms, you skip that one, then you take race. Okay? What about height in meters? You skip that one. So once you select these two, okay, you click on OK. And SPSS has given us, okay, look at the frequency table here. Okay, the percentage of females is 40%. The percentage of males is 60%. The sample size is what? I don't know. It is 5. Have a look here. There are 5 observations. The percentage, the total percentage is 100%, and so now race. Okay. Now, how many possible values did you have? 1, 2, 3, 4. Okay, race category 1, 2 observations out of 5, that comes up to 40%. So you will have absolute counts as well as percentages. All right, so once you get this, you can sketch your bar charts or pie charts. Now we can do the same thing in Stata. So let's go to Stata. Okay, if you go to Stata, right here, this is where we are. And now let's open up a file. Okay, start one. You just go to File, Open, and you go to, there's a folder for JOAS, and you highlight Start 1. Okay, and open it up. Now, to see, you go to the data editor edit window. Okay, click on it and have a look here. That's exactly the same as the raw data set you just had a look at in SPSS. You see, column 1 is for age, column 2 for gender, column 3 for weight, and column 4 for race, and the last column for height. So that's the same data set. Now let's obtain, let's do some frequency tables. Okay, let's obtain frequency tables. You go to statistics, and under statistics, you go to summaries, tables, and tests, and have a look at frequency tables, one-way table. I prefer multiple one-way tables. It works for one frequency table as well as for 2 or above. So why bother? I come straight into multiple one-way tables. And then the machine will say to you, okay, this is coming from the previous one. Okay, so now click on the drop-down menu, and let's pick the categorical variables here, gender and race. So that's all. And now after you do this, click on OK, and look at what happened. Stata gives you command number 5. Okay, although I followed the menu for doing this analysis, Stata dutifully has given me the corresponding Stata command. What's the rationale? It is reinforcing your memory. Okay, the longer you practice, you will definitely know what command to type out. Okay, the key command is what? TAB1. And is it too difficult to remember TAB1? No. TAB1, see, for frequency tables, however many categorical variables you might have in your data set, all you have to write is TAB1. TAB1 followed by 19 variables if you have 19 categorical variables. TAB1 followed by 12 variables if you have 12 categorical variables. Okay? So whenever you do data analysis, whether it is a master's or doctoral level research, TAB1 comes in quite handy. What kind of variables do you have in your questionnaire of study? Some of them are categorical, the others are continuous. So for all your categorical variables, you got to use TAB1. How difficult is it to remember this? Is it difficult at all? No. TAB1. Okay, will you remember that? See, so you write down TAB1, followed by gender and race, and Stata plays ball with you by uniquely, see now, serially numbering the command so that you internalize it, you remember it. Okay, now, TAB1, gender, race, now press enter. What happened? The command got executed. So, look at the tables here. Now, gender, females 2, male 3, the corresponding percentage 40%, and then for males you have 60%. Look, the results are identical. Now, you can copy your results of data analysis, okay, from Stata. Have a look. Okay, like this, and right-click, copy, and you go to MS Word. Okay, let's go to, I'm going to open up a new MS Word file. I hope I find it somewhere. Microsoft, yeah, where is it? Okay. I think it must be somewhere here. Microsoft Office. Yeah. I think one of them should be MS Word. Or here. Okay, anyway, I really don't know what's going on, but let's do this. I just want to demonstrate. Okay, let me go to the end of this file. Okay, right here. I will remove it now immediately. Okay, there. Just go to Stata. Okay, right here. Now, right-click, copy, and you go to MS Word. And here, right-click and paste. See, the results came through. So, you copy your results, you take them to MS Word, and you keep editing and writing. So you have done now half of the job. The next step will be to write a narrative, okay, and to sketch a graph. Okay, is that okay? Right. So what we'll do is, let's go back to the control home. Okay. Now, here we are. Okay, this is your data set. And the steps are written here. So you follow these steps. Now, to obtain summary statistics for the variable age in SPSS, let's go and apply this. Okay. To obtain a frequency table for the variable gender in SPSS, we have done this. Click on Analyze, Descriptive Statistics, Frequencies, and select the variable gender and click on OK. Can you see that? We have done that. Now let's do summary statistics for the variable age in SPSS. Here are the steps. Click on Analyze, Descriptive Stats, Descriptives, Variable Age, and click on OK. Okay, let's do that. Right, this is it. And I'm done with this one. Okay, save contents, no. So you go to SPSS. It takes a lot of memory. Now go to File, and please go to Recently Used Data. Can you see that? Start one, Recently Used Data Sets. It saves you a lot of time. Now, we are going to get, okay, summary stats for the variable age. So Analyze, Descriptive Statistics, and please go to Descriptives and select the variable age. And where it says Options, you can add a number of things like variance, the range, the standard error on the mean, and so on, the coefficient of kurtosis, the coefficient of skewness, and so on. And click on Continue and click on OK. Look at this. So you got your descriptive statistics from SPSS for the continuous variable age. So the steps are clearly written on your handout. They are not difficult to remember. Now let's do the same thing in Stata. Okay. Now if you want to copy this, highlight this. Now wherever it says output, if you highlight the output and right click and copy, okay, now you go to MS Word. Let's go to the last page right here. And then right click and paste. Look at what has happened here. Do you see this is a printout from SPSS? You see here are your results of data analysis. Okay, so the results are the same. Now let's go back to your handout. Now let's go to the front page and follow the next procedure. Right, now let's do okay, a frequency table, summary stats. Okay, this is how to do the combined layout. Okay, log file. If you want to save a Stata log file, these are the steps you need to follow. Okay, now let's do analysis. I'm mostly interested in doing data analysis here. So let's obtain, let's get one practical example of data analysis. Okay, start one. Record, generate. I want to do, this is the result from SPSS. Okay, now you open up the file. Okay, here is, now I'm on page 7. Now let's have a look at both one. This data file is based on research work done in KwaZulu-Natal. And we had a cholera outbreak at the end of 2000. And based on that, okay, some research was done by a public health student. And now look at the variables here: age in years, okay, sex, marital status, and so on. diarrheal sickness and so on, and weight and antenatal health care, postnatal health care. Now these variables were used for performing a community-based survey. So now how to obtain frequency tables for diarrhea? Now you have to say the percentage of people who experience diarrheal sickness is that much. So, okay, diarrheal sickness is a categorical variable, okay, it's a yes or no variable. So you can only obtain a frequency table. So you have to go to open up the file. Okay, let's open up the file. Okay, in SPSS, this is SPSS. Okay, I'm now going to open a file. Open. I hope it is, no, recently used data. Yeah, here we go, boss one. It's easier. So here is my data set, and the variable you are looking for is sickness. Okay, it's towards the end, and now you go to analyze, and descriptive stats, go to frequencies, and there is a variable called sickness. Okay, here it is, diarrheal sickness. And select that one and click on OK. Now here is the sickness variable, do you see? All in all, you have 181 respondents, and one means, you can see, it is a yes or no thing, eh? So 0 and 1. So 1 means they had diarrhea, and 0 means they did not have diarrhea. So 140 out of 181, the percentage will be 77.3, and those with no diarrheal sickness were 22.7%. All right, the actual number is 41 out of 181. So this is how you do frequency tables in SPSS. Now let's do the same thing in Stata software. Now in Stata software, you open up the file. This is my file. Okay, I will go to file, recent files. Okay, boss one, can you see? Here is your boss one. And you go to statistics, and then let's go to frequency tables. I go to multiple one-way tables, and I will look for the variable sickness. Okay, the drop-down menu, go to, there is a variable sickness here. That's the one. And when you finish, click on OK. So here it is. See, 41 of them did not have diarrheal sickness. The percentage is 22.65. 140 of them had diarrheal sickness. The percentage is 77.35%. So the results are okay. Now let's carry on with our discussion. See, what has happened is, look at this, 181, then frequency tables from SPSS, female, male, marital status, race, all of them are here, immunization status and so on. Now let's do summary stats here. Okay, now weight is a continuous variable. So to do summary stats in SPSS, okay, you follow these steps. Click on analyze, descriptive stats, okay, go to descriptives, select the variable weight and click on OK, and you will see the minimum is 32.87, the maximum is 78.23, the average is 54.56, the standard deviation. Of course, you have a number of other options. So this is how you do this in SPSS. Now you do the same thing in Stata. So in Stata, if you want to do the same thing, you see this is the variable, weight. So let's go and do it in Stata. You just have to go to the main menu of Stata and go to statistics, and now go to summaries. You go to summary stats, and you select the variable weight. Weight is towards the end. Okay, that's the weight variable. And let's display additional statistics and click on OK. So here it is. The Stata command is summarize weight detail. Look. Now let's interpret this. Okay, the median, the 50th percentile is 54.78. The average weight is 54.56. Okay, the smallest weight is 32.87. The maximum weight is 78.23. Okay, the 25th percentile or the first quartile is 47.67. Okay, the 75th percentile or the third quartile is 62.12. Can you see that? Eh? So the median is 54.78, the second quartile. So what you do is you can take this one, okay, copy this, okay, you right click here and say copy, you take it to MS Word, and towards the end, okay, right here, right click and paste. See, the results are taken to MS Word and you can edit it. So you can use Stata software, okay, for obtaining summary stats. You can also use SPSS for obtaining summary stats. Okay, with summary stats, remember, you obtain summary stats for a continuous variable only, not for a discrete variable, not discrete, no categorical. Okay? An example of a discrete variable is gender, which can only have two possible values, male or female. Although there are some people who say we have recently started having a third category for others. This is important. When you apply for research ethics approval, okay, category 1 will be male, category 2 female, and category 3 others. Yeah. So you just bear that in mind. Anyway, there are only 3 possible categories, and for those 3 categories, you obtain a frequency table. Okay, because gender is a categorical variable. Now, if you have a continuous variable like age in years, weight in kilograms, body temperature in degrees centigrade, you look for summary stats. Okay, you're looking at averages, okay, the first quartile, the second quartile, which is the median, the third quartile, and you should also go for the minimum, the maximum, the range, the interquartile range, and so on. The variance of estimation, the standard deviation of estimation, the coefficient of variation, and so on. So, first of all, you got to be able to recognize, okay, what constitutes a categorical variable and what constitutes a continuous variable. Because the procedures for categorical variables are different from the procedures for continuous variables. Are we clear about that? You see, this is a very important thing. I'm just saying this because every now and then I come across students who fail to distinguish a categorical variable from a continuous variable. See, for categorical variables like gender, the appropriate statistical procedure to follow is frequency tables. Okay? The possible values are finitely many, and once you get those possible values, okay, you give a narrative. Now, by contrast, for a continuous variable of study, it makes sense to talk about what? Averages, the mean, the mode, the median, the standard deviation, the variance of estimation, and so on. So you need to know, okay, how to distinguish a continuous variable from a categorical variable. That is basic step number 1. All right, so now let's move on to the handout. Now we will go to the next section. You see, by following the handout, you will come across most of the commonly used statistical procedures of data analysis. Now let's get down to, I want to demonstrate a practical application for a continuous variable. Okay, descriptive statistics from SPSS, and this variable is age. You see, the steps are written here. Age is a continuous variable, and for a continuous variable, you follow the procedure for summary stats, okay? And the minimum age is 32.87, the maximum is 78.23, the average is 54.56, the standard deviation is that much. And all in all, you have 181 observations. All of them are valid, and you can do the same thing in SPSS and Stata. So in SPSS, you can sketch a histogram, Okay, it's possible to sketch a histogram in SPSS. Okay, let's do that. You see the steps are here. Okay, open up the data set. And after that, you go to graphs. Okay, legacy dialogues, histogram, display, normal curve. Okay, can you see this? So if you follow these steps, you will see this histogram. Okay, the histogram comes up and you can see the shape of the bell curve. And now let's answer the following question. The ideal curve is the shape of the bell curve, and it corresponds to the normal distribution. Okay, the bins represent what has actually come out of your data set. So can you say these two are fairly similar to each other? Is it possible to say that? The ideal is represented by the shape of the bell. Can you see that? Okay, what has come out of your data set is represented by the bins. Okay, towards the center, you will see the bins rising up. Can you see that? And as you go to the left and to the right, what happens? There's a gradual decrease in the length of the bins. Is that right? So would it be fair to say your distribution is fairly normal? The age distribution, that is. Okay, this is about age. So you can say the ages of the people in your study are fairly distributed normally, okay? And the proof is this curve. And you can do so in SPSS and in Stata. The steps are shown. Now let's go to Stata, for example. Look, let's open up the file. It is both one. Now you go to graphics, and there is something that talks about histogram. Okay. And let's select the variable age. Okay. And now take, for example, this one, density plots. Add normal density plot. And when you finish, you click on OK. And now the histogram will come up now. Okay, here it is. Okay, there you go. I think that's fair enough. Can you see this? So the ideal curve is represented by the shape of the bell. And the actual bins are represented by the bins that rise up and so. So I would say this is a fairly normal distribution. So the ages of your people in the study are distributed normally, and this is the proof. So it's a simple exercise. You can do the same thing in SPSS as well. Okay, let's go to SPSS and have a look. You see, in SPSS, okay, let's go to graphs, and you go to legacy dialogues, and there is something that talks about histogram. And the histogram, let's talk about this variable age. Yeah, take it here, display normal curve, and select it here. And you can attach a number of things. And now if you say, OK, now the graph will come up. OK, can you see this? So you can copy your graph. Now, it depends on whether you have the license. You know, if you do not have the license, you will not have access to the software. Okay? If you have no access to the software, then you cannot continuously improve your skills. Okay? Now I'm going to share with you something that has happened at the University of Pretoria. There's a guy, he's a medical doctor. Okay? And this is a medical doctor from Malawi, and his name is Dr. Mishak Luhanga. Now, I met him in the lecture hall, and he said, look, I'm very much interested in doing some statistical data analysis, and can I start working with Stata software? Then I said, okay, let's carry on. Now, 3 years down the road, I was told, I received a letter from the CDC saying, would you like to write a reference letter for Dr. Luhanga? And the post he applied for is the post of a biostatistician and epidemiologist, okay, to work for the CDC in Uganda. And so I had to refer to how many times he had surprised me in the past by reinventing himself as a statistician and so on. So the guy kept working with the Stata software, and it took him about a couple of years, and he had a different profession. And now he's no longer treating patients, but now he's practicing statistics and epidemiology. So if you keep working and practicing with the statistical software, and if you have the passion for that, if you show enough dedication, what happens? You will have a calling. And that calling cannot be stopped. And once you get a test, the way back becomes unthinkable. Yeah, so there are many people who have changed careers. So it's a matter of practicing. Now, in order to practice, I really need unfettered access to a software I can call my software. No strings attached. I really need unfettered access. I mean unfettered. At any time of my convenience, I've got to have access to that software. If that's not the case, I should rather not have it at all. Okay, that's me. So that is why I decided to work with a software with a permanent license. Okay, so you keep working, what happens? You sharpen your skills. Before you know it, you have developed the skills, so much so you can even rely on yourself, and you can provide assistance to other people. So everybody does that. It's not only you, and that's why you need to practice. So let's go back to, and when you practice, okay, you will need the handouts. Now let's go back to these handouts. Now the steps are shown here clearly. And so look at this, for example, interpretation of results. Okay, the null hypothesis says the age distribution is normal. In other words, the ages of people is normally distributed. Now the alternative hypothesis says the variable age is not distributed normally. And now what you do is, from your test, okay, the machine has given you a small p-value. Can you see this? Okay, the p-value is smaller than 0.05. And therefore, you need to reject the null hypothesis and conclude that the age variable is not distributed normally at a 5% level of significance. Okay, so eye inspection may not be necessarily the same as computed results. When you compute a result based on probability values, you will find reliable answers to your questions. Now, let's go to the so-called chi-square tests of association. The rationale is clear. In any postgraduate level study, students perform tests of associations. They always wonder whether there is a statistically significant association between two variables, x and y. The null hypothesis always says there is no significant association between these two variables. The alternative hypothesis says there is a statistically significant association between the two variables. You reject the null hypothesis if you have a small probability value. If you have a large probability value, you cannot reject the null hypothesis. Okay, a very good example is here, and in these handouts, there is a cross-tab association which is done between diarrheal sickness and the practice of boiling drinking water regularly. The null hypothesis says whether you boil drinking water at home or not, you are equally vulnerable to diarrheal sickness. In other words, boiling water does not help at all. The alternative hypothesis says there is a relationship between the practice of boiling drinking water regularly and being less exposed to diarrheal sickness. Okay, is that clear? So you reject the null hypothesis at the 5% level of significance if your p-value falls below 5%. If your p-value is above 5%, then you will be required to accept the null hypothesis. All right, so now let's do this exercise. Okay, this exercise is, have a look at these two variables. The row variable is sickness, the column variable is boiling. Now the steps are clearly written. Now have a look, analyze, descriptive stats, click on cross tabs, okay, and select the variable sickness as a row variable, select the variable boil as a column variable, and click on statistics, and click on chi-square tests, click on continue, click on OK. Do you see now? These are the steps for SPSS, provided that you do have the license. Now let's go there. Now you go to SPSS. Okay, here are your steps. Now, analyze, descriptive statistics, and there is something that says what? Cross tabs. Can you see that? Okay, and as a row variable, select the variable boil. Okay, let's look for the variable boil. Here it is. As a column variable, let's select the variable sickness. Now, here it is. Select it as a column variable. And where it says statistics, can you see that? You click on Pearson's chi-square test. This is it. Yeah, the chi-square test. And when you finish this, you click on continue and click on OK. And SPSS will give you the following result. And the p-value I'm referring to is here, 0.022. You see? That's the p-value I'm referring to, 0.022. Pearson chi-square. You see, the calculated value of the chi-square random variable is 5.245. Okay, the probability value, the p-value, it's a two-sided probability value, is 0.022. Okay, now SPSS calls a p-value SIG. SIG is an acronym for observed significance level. Okay, but a better phrase would be p-value, okay, probability value. Now 0.02, can you see that? So now you can make a decision. 0.022 is less than 0.05. Therefore, you need to reject the null hypothesis. And what happens when you reject the null hypothesis? You conclude that there is a statistically significant relationship between the practice of boiling, drinking water regularly, and the likelihood of minimizing the likelihood of what? Diarrheal sickness. The two variables are significantly associated at the 5% level of significance. Now, what happens if you lower your level of significance from 5% to 1%? If the level of significance is lowered to 1%, meaning 0.01, your p-value would be bigger than 0.01. Is that right? And because the p-value is bigger in magnitude than 0.01, you would be required to accept the null hypothesis. So the outcome of your hypothesis testing depends on the level of significance of your test. See, in many studies, in socio-behavioral studies of this type, we let the level of significance be set at the 5% level. Okay? In many socio-behavioral studies, the probability value has got to be below 0.05 in order for you to say, I've got something. Okay? In clinical trials where the stakes are high, the level of significance of a test is very low. Okay? When you run clinical trials, the stakes are high. You've got to be dead sure. In the socio-behavioral or socio-economic studies or demographic studies, the stakes are not that high. People will not die. Okay? It's not desirable to arrive at the wrong decisions. However, nobody will pay for such a mistake with their life. So the stakes are not that high. So you leave the level of significance at the 5%, and to the best of my knowledge, in TUT, okay, most of the times, your level of significance is set at the 5% level. Does that, anybody who, is it your first time to hear about the level of significance of a test? Level of significance of a test. Okay, we leave it at the 5% level. Please remember that. Now, based on results obtained from SPSS, here is your probability value, 0.022. It is less than 0.05. Therefore, we need to conclude that there is a significant association between the two variables at the 5% level of significance. Now, let's do the same thing in Stata. Now, in Stata, you just have to go, look, you go to statistics, okay, and now let's go to classical tests of hypotheses, and after that, not classical, let's have a look here. Yeah, can you see this? Two-way table with measures of association. Can you see this? Two-way table, sorry, that's what I need. And then the row variable will be Boyle. Okay, let's pick up Boyle. Here it is. And the column variable would be sickness. Yeah, you find this variable. And the test statistic is Pearson's chi-squared. And let's ask for expected frequencies, relative frequencies. And finally, let's click on OK. And here is your Stata printout. And the corresponding command is, there you go. Do you see now the p-value here? 0.022. It's the same p-value. Whether you use Stata or SPSS, the p-value is the same. And the decision is clear. At the 5% level of significance, there is a significant association between the two variables. So the guy who did this study in Pietermaritzburg, okay, he made a recommendation saying community health workers must go door to door to places like Ishowe, Mpangeni, and so on, and educate rural mothers about the benefits of boiling drinking water regularly. Guess what happened? Somebody said, okay, I'm prepared to boil drinking water, provided that you give me firewood. Do you know how difficult it is to get firewood? Yeah. It would be better to talk about what? Paraffin. And how many rural households can afford to have paraffin for boiling water? They cannot afford that. And do they have electricity? Well, that is a problem related to infrastructure. Okay? So, finally, out of further research, a feasible solution, underline the word feasible, a sensible, feasible, realistic solution was worked out. What? Using JIK, the detergent JIK. Have you seen that? J-I-K. Disinfectant. You get yourself a bucket of water and put in a drop of JIK. What happens? After a while, okay, all the dirt settles down. Okay, the water may not be tasty, okay? However, it's a fair price to pay. It's better than not. Do you see now the choices are having diarrhea or else, having a bus test, okay? So it was a fair price to say. Now, when the student made his presentation, okay, he concluded that now firewood had to be. Now, everybody said, where the hell is firewood going to come from? You should rather talk about paraffin. Now, paraffin, how many rural households can afford paraffin? They cannot. And talking about electricity, it doesn't even make sense. So the only feasible solution turned out to be the use of the disinfectant JIK. So they went door to door and they enticed rural households to use JIK. And believe you me, they were not impressed. They say, no. This, yeah, so the thing is, first of all, you do research, you come up with your research findings, and then based on your findings, you propose a solution or a recommendation, and whether that recommendation flies, it's a matter of you doing further research. Okay? So now that's the research done by the student. Now let's go back to our results. Here it is. Now in this study, now the p-values are here. Okay, here is your p-value, 0 to 2. And the interpretations are given here. The p-value, can you see this? All the results are interpreted. Now, how to obtain a single frequency table? Have a look. To get a single frequency table, this is what you do in Stata. And you just do TAB, sickness, and so on. How to obtain 2 or more frequency tables in Stata? You use TAB1. Yeah. And now, how to perform cross-tab analysis in Stata? These are the steps. Okay, the steps are provided. And by looking at these steps, you cannot go wrong. You see, what I've done is, when I prepared for this lecture, I had to type out the steps to be followed. Once you have the steps, the next logical question becomes, do I have the software? So you get the software, okay? Get yourself the software on your own laptop. And I want to say this. I've seen a student who really felt bad when we said, you got to have yourself a laptop. You see, the guy said, why do I have to have a laptop? It's useless. I've got a secretary, and I tell her to type anything I want. And I really do not have to have a laptop for myself. And I don't think I should sit down and do data analysis. So now the guy thinks his secretary should be doing his data analysis on his behalf. Can you believe this? One day he made the biggest mistake of his life. Okay, he got his secretary to submit a designated assignment. That degree of arrogance. Come on. Yeah, so he was summoned, and there was a meeting, and he was given a choice to quit or behave himself. So finally, he got the message. You see, your secretary cannot and must not do your assignment on your behalf. It's a learning and teaching process that has got to occur in your person. And you need to demonstrate mastery of those concepts in an independent assessment environment. So is the secretary going to come here and write the test on his behalf? Certainly not. So he made a choice, and he acknowledged that he needed counseling. So the guy who gave him counseling said, now let's go back to the basics. I would like you to agree or disagree with me. He said, getting the MBA, how important is it? Does the MBA mean anything to you? Will it transform you? Then he said, okay, the MBA means a lot to me. I will be able to do a number of things with the MBA degree. So I acknowledge that I'm not wasting my time, and it is time for me to sit down and master those skills. So he went to University of Pretoria. He took a short course. Yeah. You see, by taking a short course, okay, what happened? He mastered basic skills. By using those basic skills, his morale was boosted. He told himself that he could do anything, provided that he was committed. So he even decided to go to a gym, and it was the right decision. So now you find him at the business school on Saturdays and Sundays, and we had to chase him from the venues close to midnight. You know what? The security guard wrote a letter of complaint about him, saying this guy must be barred. So, so we decided to make an exception, and now he is one of the top performing guys. Now he's now saying he deserves the Top Achievers Award. Yeah, so See, so practice it. When you practice, you get a calling. You see, when you master a skill, internalize that skill, and when you know what needs to be done at the tip of your fingers, what happens? You get a calling. There are people with no calling. There are people with no dreams, no vision, no purpose in life. Yeah. You are only a human being when you have a dream, when you have a calling, a purpose in life. And to be that, you got to master skills. So you must not regret the sacrifices you need to make in order to acquire a skill which you can confidently say, I do have this skill. You see what I'm saying? Eh? So it's a very important thing. And you must not regret your time. Okay, the time you spend mastering those. Okay, it's probably one of the most honorable things you can do. So what we'll do is now just proceed with this. Okay, now this has been done. The null hypothesis, look at how it's written. The null hypothesis, whenever you do research, you test a null hypothesis. Okay, the null hypothesis, the word N-U-L-L. Okay, null means something of no consequence. Okay, the null hypothesis always says there is no statistically significant association between the two factors. The alternative hypothesis says the contrary. Okay, it says there is a statistically significant association between these two factors. So now you reject the null hypothesis if your p-value falls below 0.05 at the 5% level. Okay, now let's do the one sample t-test. Now I'm going to demonstrate this one quickly in SPSS, and then we do the same in Stata. The steps are shown. Okay, let's do that quickly. Okay, now please let's go to SPSS and open up the file boss1. Okay, here the plan is to do the one sample t-test. Okay, analyze, compare means. Okay, click on the one sample t-test, test variable, select age. Okay, test value 45, click on options, confidence interval 95, click on continue, click on OK. You see the steps are written, and Stata will give, SPSS will give you this printout. So in the interest of saving some time, just have a look. The handout gives you the steps, followed by what? Printouts. So follow the steps, reproduce the results. So try to get yourselves a copy of SPSS. Right. So once you get SPSS, follow the steps. And you know, these lecture notes are made. They are tailor-made to postgraduate level students who are required to do data analysis. Okay, these are people like you. So if you go through these and master those skills, I'm sure you will be able to do something similar. Okay, you can replicate these and adapt these to what it is you wish to do. So just see how it's done. And now the one sample t-test in Stata. Okay, here are the steps. Okay, similar steps. You go to Stata and you click on analyze, statistics, summaries, and blah, blah, so on. Now, Stata will give you the following printout. Okay, now when you look at this printout, you will see the p-value. Okay, here is your p-value. The one in between. See, you have three possible p-values. One for a left-sided alternative hypothesis, one for a two-sided alternative hypothesis, and the one on the right-hand side for a right-sided alternative hypothesis. Okay, the one you will need most is the one in the middle. So have a look at this p-value. Okay, it is 0. So what does it mean? The p-value is smaller than 0.05. So what do? You reject the null hypothesis. So what does it mean? Now, the mean age is 45. You see, the claim that the average age of all the respondents in the study is 45 years cannot be accepted. Okay? Your p-value is what? 0. You need to reject the null hypothesis. Okay, so for the record, now what is the mean age? Okay, if you analyze your age Can you see this one? What's the mean age? 41. Can you see that? 41. So in your hypothesis, you are saying the mean age is what? 45. It is far away from 41, which is why you end up rejecting the null hypothesis. Right. Now let's do how to perform two-sample unpaired t-test in SPSS. Here are the steps. Okay. In SPSS, now remember the two-sample unpaired t-test is commonly used for comparing teaching methods, feeding schemes. You can test two competing methods. Example, you may have two painkillers. Okay. You may have painkiller with brand 1, painkiller with brand number 2. And the two manufacturers make claims. And what do? You test the claim that says the two painkillers are equally effective against the alternative hypothesis that says these two painkillers are not equally effective. One is better than the other. Okay, so the null hypothesis says the two means are equal. The alternative hypothesis says the two means are not equal, and therefore you obtain a p-value. You reject the null hypothesis if your p-value is below 0.05 at the 5% level of significance. So now have a look at what happened here. If you see this comparison of, first of all, before you compare means, you need to compare variances. Okay, this is very important because apples can only be compared with apples. Oranges can only be compared with oranges. You do not compare apples with oranges. In order to compare two entities, you got to place those two entities on an equal footing with each other. Are we clear? If you haven't done that, you are not comparing left and right. Okay? It is a biased setup. So what you do is, first of all, you make sure that the two entities being compared with each other are placed on an equal footing with each other. The only variable based on which they are allowed to differ is the variable of comparison. Are we clear? So now, first of all, you compare variances before comparing averages. It will tell you whether or not comparison of averages is a sensible thing to do. If you know that you have apples here, you have oranges there, is it necessary for you to even do the comparison? No. An orange is supposed to test differently in comparison with an apple. Is that right? Do you have to do research to conclude that an apple tests differently in comparison with an orange? No. That would be an abuse of resources. However, it does make sense to compare oranges from Stellenbosch with oranges from Mpumalanga. Do you see what I'm saying? You can make a comparison because you are comparing oranges with oranges. So after you do comparison of variances, if you conclude that the variances are equal, then comparison of averages makes sense. If you conclude that comparison of if the variances are not the same, then it means the two populations being compared are completely different from each other. And you must not be worried. You shouldn't be surprised that the averages are also different. So that is why this test is always preceded by comparison of variances. Before you compare averages, you got to compare variances. Now, look, comparison of variances. Now, when you do this, the p-value was 0.51. Can you see this? This is a bigger number. Therefore, the variances are equal. So the variances are equal. Therefore, comparison of averages is sensible. And now, when you compare the variance, the averages, you will see another p-value, which is 0.448 and much bigger than 0.05. Hence, okay, the averages are also equal. So a conclusion about this one, these are similar populations with equal variances, and the averages are also equal. So that's the conclusion. And many people have done research based on the two sample test, okay, like this. And now we should talk about the this exam in Stata. The same procedure in Stata could be followed. Now in Stata, first of all, you do the SD test. And after you do SD test, you do T-test. Okay, the steps are clearly written here. And by following those steps, you compare the variances, you get the same result. And after comparing the variances, you do comparison of the averages, and you get the following printout from Stata. The p-values are the same, and the null hypothesis and the alternative hypothesis are written here. Let's just have a look at this. Okay, let's just see. The null hypothesis H0 says the two populations are similar with regards to average income. The alternative hypothesis says the two populations are not similar. So since the p-value, okay, 0.8847 is much bigger than 0.05, the null hypothesis cannot be rejected at the 5% level. So we conclude that the variances are equal. If the variances are equal, the populations are similar. Now it makes sense to compare averages. Okay, so to compare averages, here are the steps to be followed. Okay, here are the steps. So if I were you, you know what I would do? I would get myself a laptop. I would install Stata software and try to get SPSS. And what do? I sit down and go from page 1 to the last page of the handout, step by step. Okay? I will start doing this exercise by first opening up a folder in C. Okay? You copy all your files into the C boss directory, as we said in the beginning. Once you do that, what do? You go to page 1. You start from the first paragraph and you do not stop until you reach the last one. You carry on. And next day, you do this again. 3 days later, you do this all over again. And then you repeat that. You may do it maybe 10 times, 15 times if you wish to do so. And every time you repeat the exercises, your skills become better and better. And then it will be time for you to apply those in your own study. Yes, think of a similar study and then apply these techniques in your own study and convince yourself that you are capable of doing this. There's a lady who asked someone to do data analysis for her. I think the lady was sick most of the year. She was sick, and I could see she was stressed out. And she got somebody to do data analysis for her, data capturing, analysis, interpretation, and so on. And obviously, this guy didn't pay attention. So he unilaterally ended up doing data analysis he was never asked to do. So he defeated the purpose of her study. Do you see what I'm saying? You see, in her proposal, she was supposed to do ABCD. The guy made his own changes unilaterally without even bothering to tell her, and he ended up doing something else. And what he did was picked up by the examiner. There are 2 external examiners. One of the examiners picked it up because he was familiar with the study. Can you believe this? A small world. He had used data sets from that study in class for teaching. And so he said, "Are you kidding me?" Then, to his complete surprise, he confirmed that it was the same study. And then he said, "But I never asked her to do this." Yeah, so finally he said, "This must be done all over again." Yeah, so she was lucky. She apologized and she did everything properly. And so it basically means the 1.5 years she has had to spend with her assistant didn't mean anything. So it was a painful exercise. You see, you lose 1.5 years of your time, you lose your money, and all for nothing. So it's better to rely on yourselves. Yeah, you be in control. Now, to be in control, you pay attention to the little details here, the steps, the baby steps, I might say. So once you master those, you will say to yourself, this is similar to what I'm thinking. Therefore, let me think of a similar problem and let me do this by myself. Now, in that process, if you make, let's say, 20 mistakes, it doesn't mean anything. It only means that you are learning out of your mistakes. So finally, you develop confidence by practicing. Now have a look here. So the steps are here, reproduce the results, and you can apply the same thing here. So have a look at this exercise now. Comparison of two independent samples. Now here are the steps. And you see, first you do comparison of variances, followed by comparison of averages. And the p-values, can you see? 0.4528. It's the same p-value we got from SPSS. And it's a large p-value. Therefore, you conclude that the averages of the two groups are the same. You see, first we concluded that the variances are the same. You see, when you conclude that the variances are the same, you are basically saying the two populations, the parent populations, from where the samples were drawn were not different from each other. They were similar with each other. Therefore, comparison of averages does make sense. You are comparing oranges with oranges. So that is what has been demonstrated here. Now let's quickly go to the so-called two-sample paired t-test. Instead of unpaired, you may also have paired. Okay? Instead of the two-sample unpaired t-test, we may now talk about the paired sample t-test. Okay, I will give you an example. Okay, the paired sample t-test is used by students who take a measurement at the baseline study, they keep the record, and they intervene. After the period of intervention, they do measurement once again. And they see whether or not, as a result of the intervention, your respondents have benefited. Does that make sense? You see, example, think of army officers who are required by law to be physically fit. Have you seen, when last did you see a colonel, for example, or a brigadier general, or a major, or a captain? You just try to think of members of SANDF, okay? And when you see them, please remember what they looked like, their physical fitness. Are they battle ready? Have you ever seen them fighting a war? Do you see now? Now this is very important. You see, we send some members of the SNDF to Rwanda. We have sent them to the DRC. Some of them have been to Somalia. You do remember, Yeah. So they are required to serve on foreign missions. Now, in order for them to be successful, they got to be physically fit. Do you see what I'm saying? Now, if you are a soldier, you got to be physically fit, and you got to be perfectly balanced. You got to do physical exercises on a daily basis, and so on. Now, there was a training given to 10 army officers, okay, with the intention of enabling them to shed some of the body weight. Okay? At the end of the training period, okay, you would imagine these guys surely must have benefited from the training exercise, and you would be surprised if you see that nothing has changed. So the null hypothesis says, by virtue of the physical training the army officers have had to take in the last couple of weeks, okay, there has been a significant reduction in the body weight. The alternative hypothesis says, irrespective of what you claim you have done, nothing has changed. You see? And you reject the null hypothesis if you pick up a small p-value. At the 5% level, your p-value has got to be less than 0.05 in order for you to reject the null hypothesis. The null hypothesis says there has been no significant reduction. Okay? The alternative hypothesis says there has been a significant reduction. And if there is a significant reduction, the reduction would be attributed to what? The intervention you proposed. It is good news to the guys who proposed the intervention because it's a proof that the intervention does yield tangible results. Now, let's have a look here. There's an example where these guys did the exercise, and it's in another note, but this is a similar thing. Look at this. What's the p-value here? Okay, have a look here. The p-value is 0. Can you see this? Yeah, it is 0. It's a small p-value. What does it tell you? It means, okay, is the difference significant or not? There is a significant difference because the p-value is small. Yeah, so now this is the paired sample t-test. Now I will give you an example of the paired sample t-test. There was a program, a counseling program given to some students, and the null hypothesis says as a result of the training program, the participants have benefited and so on. And you administer a test. The best way to administer is to assess whether or not the respondents have benefited from the training program is to give them an assessment exam. Okay, standardized assessments. Okay, you do those assessments twice. The first round at the beginning. Okay, the second round assessment at the end of your training period. So a small p-value means the people have benefited significantly. A large p-value means they have not. All right, so now let's go to, after this, now I want to briefly talk about the one-way analysis of variance. Okay, here is an example. The one-way analysis of variance. We have 4 brands of painkillers, and the null hypothesis says, okay, the 4 painkillers are equally effective. The alternative hypothesis says the 4 painkillers are not equally effective. So because the groups being compared are 3 or more, you need to use the analysis of variance table. Okay, we have to use the analysis of variance test because, okay, the number of groups being compared is 3 or more. If you have 3 or more groups, you cannot use the 2-sample paired t-test or the 2-sample unpaired t-test. Okay, so now you have to use the the one-way analysis of variance, and the variable of interest is the time taken to bring about relief from pain. So our only interest is in the time taken to bring about relief. We have no other interest, therefore it is a one-way analysis of variance experiment. Now, the null hypothesis says, okay, there is no difference between the 4 brands, okay, with regards to the time taken to bring about relief from pain. The alternative hypothesis says there is. So when you do this, okay, you open up this file. Now in SPSS you get the following printout, and let's interpret here. Look at the p-value. The one important thing you should see is the p-value, and that is 0.015. Can you see that? It's a small p-value. It's smaller than 0.05. So there is a difference between the 4 types of painkillers. They are not equally effective. Some are more effective than the others. Okay, now you can do the same thing in Stata. Have a look. In Stata, when you do that, you will get the same p-value here. The steps are written. Here is your p-value. So you conclude that the 4 painkillers are different. Now you can go further and say, why are the 4 painkillers different from each other? Is it because of the differences between 1 and 2, 1 and 3, 1 and 4, or 2 and 3, 2 and 4, or 3 and 4? Can you see that? There are 4 of them. Now, you can do this kind of experiment, okay? This is a multiple comparison test, and when you do this, okay, you will see a p-value here. You see, wherever you see a small p-value, it means those drug types are the painkillers are different. Now 1 and 4, can you see the p-value 0.001? So 1 and 4 are significantly different. The next one is 2 and 4, 0.034. It's still below 0.05. Okay? The others, no. Have a look at 0.960. It's a large people. What does it mean? 1 and 2 are similar. Okay? For 3 and 1, 0.078. Okay, they are similar. So it basically means 1 and 4, can you see this? 1 and 4 are significantly different from each other, and so are 2 and 4. But the biggest difference is attributed to 1 and 4. The second biggest difference is attributed to 2 and 4. See, the smaller the p-value, the bigger is the difference. So you can do that, and there is a student who has used the one-way analysis of variance for doing the MBA dissertation. She was interested in comparing 3 companies. Okay, 3 of them are supposed to provide similar services, and she picked up a difference. And her main contribution says, you see, there was service provider number 3, and they needed a lot of capacity building, and they were not ready to be given that assignment. Okay, so she made a meaningful contribution. She handed over a copy of her findings to the people in charge, and she recommended training. Okay, so training was provided, and with that training, I think they benefited a lot from that training. So you just have to apply this one. Now let's quickly go to multiple linear regression analysis. I want to demonstrate this one. You see, multiple linear regression analysis is very important. In many economic studies, students use multiple linear regression analysis. Now in this particular example, okay, let's open up this file. I've given you this data set. So our variables are the following. Weight is a dependent variable, and the independent variables are age, income, malnutrition, gender, and frequency weights. It's a weighted data analysis. This data set comes from Orange Farm. And have you been to Orange Farm? And that's a place where you have malnutrition, and there are children who are exposed to, they have nutrition-related problems. And this is a study that was done in order to assess, okay, how effective a feeding program was. So now have a look here. Now the body weight is a reliable indicator, okay, of malnutrition, the body weight. So for any specific age, okay, you got to know the corresponding weight for a healthy child. Okay? Now, there are measures, like indicators like, we can measure body for height, weight for age, and so on, anthropometric measures. So if you look at this, age is one of the dependent variables. Income, standardized income, you have the severity of malnutrition, then you have gender, and you have frequency weights. Now when you perform multiple linear regression, okay, you just this, and the fifth line of this is a result which I got from SPSS. Okay, the same result is obtained from Stata. Okay, by following the steps, you will be able to conclude this. Results from SPSS, they are the same. So let's go to this printout. Now, the first thing you do is to go to the p-value column. If a variable is important, the p-value will be small. So when you look at age, okay, have you seen this one? Now the p-values are here. So now let's use the frequency weights. And if you do the frequency weights, let me use okay, here it is. Yeah, I've used the weights here. Okay, this is the table you have to see. Look, all the p-values here, they are smaller than 0.05. Can you see this? They are small p-values. And you should see the adjusted R square. The adjusted R square is above 75%. It shows you that your fitted line of regression is highly reliable. And you should also see, okay, the standard errors here. The standard errors, okay, here are the standard errors. They are so small, okay? And the results are highly reliable. Now, which one is your most important predictor variable here? Can you see? Gender. Can you see that? You see, the gender has the largest coefficient, 6.95, nearly 7. So gender is the most powerful indicator from among your predictor variables. So this value, 6.95, is an objective measure that shows you how important the predictor variable is. Now, next to gender, you should go to income, household income, 5.2. It's also important. And now, the fitted line of regression is written as weight is equal to, okay, here it is. This is the fitted line of regression, 2.65 plus 0.84 multiplied by age, 5.28 multiplied by income, minus 1.82 multiplied by malnutrition, plus 6.96 times gender. So by using this fitted line of regression, you will be able to fit a model. Okay, how many unknowns do you have here? Weight, age, income, malnutrition, and gender. There are 5 of them. If I give you any 4 of the 5, you should be able to figure out the value of the 5th variable. Does that make sense? That's the goal of multiple linear regression. Once you fit a model, by using the fitted model, you can answer a number of research questions. So in this case, your fitted line of regression is the one shown here, and you can apply the same technique. Now, in multiple linear regression analysis, remember that your dependent variable of study is continuous. Okay, in this case, your dependent variable of study is weight in kilograms. It is continuous, therefore you had to use multiple linear regression as a procedure for data analysis. If your dependent variable of study is not continuous, if it's dichotomous, instead of multiple linear regression analysis, you will have to use a non-linear regression procedure, such as binary logistic regression analysis. Okay, will you remember that? Yesterday we have spoken about it briefly. If you have a dependent variable of study which is dichotomous, then you need to use a non-linear regression procedure, and the best choice would be to use binary logistic regression analysis. Okay, just remember that many students at the business school do that. Now, let me refresh your memory. Now, in the case of the study done by Naledi, the dependent variable of study was about succeeding in getting the loan you needed for your business operation. Sorry. Sorry about this. Okay, so what you should do is just remember this. If your dependent variable of study is dichotomous, like a yes or no variable, you use a binary logistic regression analysis model. And there's an example here. I want to show you that before I finish off, okay? Let's quickly go to that example. Yeah, here it is. This is an example from logistic regression analysis. Please, let's have a look at the variables, okay? Now, in this case, the data set to look at is logistic.sav, and the binary dependent variable is sickness. Okay, can you see sickness? Okay, it's yes or no. Okay, the dependent variable of study is sickness. Sickness is a yes or no variable. Okay, the respondent has diarrheal sickness or else free from the disease. So it's a dichotomous dependent variable. Okay, and it's not a continuous variable. Now you use binary logistic regression analysis to fit a model. Now let's do that quickly. So open up the data set logistic.sav in SPSS. Okay, click on analyze. Here are the steps, regression and so on. Do binary logistic regression. And when you finish this, here is your fitted model. And you get odds ratios. Odds ratios are denoted by exp to the power. You see, look, exp means exponential, okay? E to the power of beta hat, okay? You take the exponential value of the fitted regression coefficients. So here are your estimated results. Look, by looking at your estimated results, okay, the odds ratios, you will tell. Now, odds ratios that are significantly different from 1. Okay, the p-values must be less than 0.05. So the most important predictor variable is boiling water. You see, 12.208. Now, this variable is most important, okay? And boiling water is now associated with an odds ratio of 12. So if you interpret that result, you will say a child whose mother does not boil drinking water regularly is exposed, okay, 12 times to diarrheal sickness in comparison with another mother who boils drinking water regularly. That's it. So boiling drinking water is the most important predictor variable. And the reason why we used logistic regression analysis here is because the outcome variable or the dependent variable is diarrheal sickness. It's a yes or no variable. Right. Now, the corresponding printout from Stata is the following. Okay, you do follow these steps, and the printouts are quite similar right here. Can you see? The odds ratios 12.20. They are similar odds ratios, and you can assess the degree of reliability of your fitted models by taking the classification table. Okay, here it is. The overall percentage of correct classification is 64%, and the percentage sensitivity is 26. Percentage specificity is 96.59. Now, let me interpret this. Sensitivity means if there is a child who is at risk of diarrheal sickness, okay, will the model guide you accurately or intelligently to the child who is at risk? If sensitivity is high, your fitted model will be a good guide. It will take you to the child who stands to benefit from intervention. Okay? However, the percentage sensitivity is what? 26.77%. So your fitted model is not so good at detecting or identifying children who are at risk of diarrheal sickness. Because it is too blind to see them, okay, it will not guide you to where they are. So you cannot use this model for intervention. Specificity is the other way around. Okay, if a child is here and if the child is not at risk of diarrheal sickness, how efficiently does your fitted model guide you to the child who is free from risk? Look at the percentage, 96.59%. So your fitted model does very well on children who are not at risk, but it does so poorly on children who are at risk and who might benefit from intervention, assuming that intervention comes in quite handy at the right time. You can only intervene if somebody alerts you. If you are not alerted in good time, what happens? You may have the capacity to intervene, however, you fail to intervene. So all in all, this fitted model cannot be a good model because percentage sensitivity is poor. It had to be at least 50%. Now it is 22%. So you see, what we need to do is to acknowledge two things here. First of all, your dependent variable of study is dichotomous. Okay, it's about diarrheal sickness or no diarrheal sickness. It's not a linear regression model. This is a non-linear regression model. So what you do is, now the assignment is clear. You get yourselves, now I think everybody should give you their email addresses, or you have their email addresses, eh? All right, now let's make an arrangement for you guys to install Stata software, okay? Install Stata software and open up these lecture notes, go to page number 1 and reproduce the results you see in the handout. And all the raw data sets are there. If you sit down and reproduce everything you see in the handout, if you can pull out that by yourselves, you can congratulate yourselves because some learning things are taking place. Please, you should keep practicing. And the Stata software also has the user's guide manual. You must not forget that. Let me actually demonstrate this quickly. Here it is. If you go to start, all programs, something S, okay, Stata. Okay, yeah, here. Now when you go to Stata, can you see this? You see the software is here, plus Stata documentation. Now if you click on the documentation, this is the complete user's guide manual. Okay, it will show you what to do, how to do data analysis and so on. Yeah, so you have the user's guide manual as well as the software. You have the data sets, you have the handouts, and reproduce what you see in the handouts. And if you have any, if you, for example, decide to use Stata software or SPSS to do data analysis, and if you get stuck, what you need to do is send an email. Now we'll make a plan to make an appointment, okay, one at a time. And we just make sure that the students get the help they need. Is that correct? Yeah, you see, this is a continuous program in which the students get assistance, okay, in analyzing their data sets. You may get stuck with interpreting your results. Maybe you may get stuck in analyzing. So I think you guys will have to work with Yoas and he will guide you. Is that okay? All right, I think let's call it a day, and that should be enough. Thank you.